Today I am going to explain about networking problems in computer network association. Problem 1, it is desired to send a sequence of computer screen images over an optical fiber. The screen is 3840 by 2160 pixels, each pixel being 24 bits. These are 60 screen images. What data rate is needed? Here we can simply calculate pixels per image by multiplying 3840 by 2160, which gives number of pixels per image. And we can also calculate bits per image. Here in the question it is given as each pixel being 24 bits. So we can calculate the number of pixels into 24, which gives number of bits per image. Here in the question it is also given that 60 screen images per second. It is images per second equal to 60. The data rate is simply calculated by multiplying number of bits into 60, which gives us 11.94 gigabytes per second. Next, question 2 is that television channels are 6 megahertz wide. How many bits per second can be sent if 4-level digital signals are used? Assume a noiseless channel. Noiseless channel is the channel where there is no corruption for a channel and the transmitter signal is the same as the output signal. So that is a noiseless channel. Here the number of levels is given as 4. According to Nyquist theorem, the data rate can be calculated by twice the bandwidth and by multiplying it with the levels, log of levels base 2. So here 4-level digital signals are used, so the levels are 4. Log 4 base 2 value is 2 and the bandwidth given is 6 megahertz. 6 megahertz can be written as 6 into 10 power 6. Then the data rate can be calculated as 2 into 6 into 10 power 6 into 2, which gives us 24 megabits per second. And the third question is that if a binary signal is sent over a 3 kilohertz channel whose signal to noise ratio is 20 decibels, what is the maximum achievable data rate? So according to Shannon capacity theorem, the signal to noise ratio should not be in decibels. It should be converted with the formula 10 to the power of decibel by 10. Here the decibel rate is 20 decibels. So the signal to noise ratio is converted from decibel to linear, that is 10 to the power of 20 by 10. 20 by 10 is 2, so 10 square is 100. Then the bandwidth is calculated using the formula, which gives 19.97 kilobits per second. Question 4 is 10 signals, each requiring 4000 Hz, are multiplexed onto a single channel using a FDM. What is the minimum bandwidth required for the multiplex channel? Assume that the broadbands are 400 Hz wide. So here given each signal is 4000 Hz and the number of broadbands is 1 less than the number of signals, which is 9. Total broadband width is 9 into 400. 400 is broadband width wide. So 3600 Hz. Total bandwidth is the 43,600 Hz. Question 5 is why has PCM sampling time has been set to 125 µs. The sampling time of 125 µs corresponds to an 8 kHz sampling rate. That is 1 by 125 into 10 power minus 6 equal to 8000 samples per second. This is the twice the minimum audio frequency, which is 4 kHz, satisfying the Nyquist theorem. Is that what signal to noise ratio is needed to put a T1 carrier on a 1 megahertz line. T1 carrier is 1.544 megabits per second bandwidth, which is 1 megahertz approximately, 2.83 decibels. And the seventh question is, a cable TV system has 100 commercial channels, all of them alternating programs with advertising. Is this more like TDM or FDM? This is like FDM, frequency division multiplexing. With question 8 is that a cable company decides to provide internet access over cable in a neighborhood consisting of 5,000 houses. So here the minimum rate guaranteed is 2 megabits per second. So 5,000 for 2 megabits per second is 10,000. And the number of cables can be calculated by, here in the question it is given that 100 Mbps per cable. So 10,000 Mbps by 100 Mbps per cable, so which gives us 100 cables. Thank you.